principles of power distribution. Okay, so from the beginning we have got generation, and then this generation, the power is transferred to the transmission system, and then to the sub-transmission system, and then it comes to a distribution system. This distribution system can be HV distribution, something like 33, 22, or 11 kV, or it can be low voltage, LV, something like 600 volts, something like 400 volts, or something like 415 volts, or single phase 220 volts. So what are the things that are important? What are the principles of this power distribution? So the first and foremost is the safety. Safety of the personnel, and of course safety of the asset, safety of the plant. Second thing, okay, so when safety is established, the customers, the consumers would like to receive a reliable power that is without interruption, that is without outage. In other words, they would like to have continuity of supply. They don't want to have any outage unless there is a severe fault. And then high quality electric power. High quality, it means that in terms of the voltage magnitude, in terms of the, let's say the frequency, there mustn't be any variations or something like that. They would like to have a system which is stable, which is high quality. And then prevention of load-related problems. If the load changes, if you have got a load growth or something, they would like still that power distribution system to sustain and to handle that. Now the issue is this. We have got two options. One of them is AC and another one is DC, both possible for distribution, right? But there are some advantages for AC, like higher efficiency of transmission. This is by means of equation. Minimizing the voltage drop. How? By means of that tap changer on the transformers. Transformation of AC voltage is easy. Yeah, so whenever you're working with AC, basically you can use transformers. And basically the concept is very easy. But when you are using DC, basically in terms of controlling, in terms of changing the voltage level, you would be in need of power electronic devices, control devices. And that can be both expensive and a little bit difficult to implement. So these are kind of comparison between the two systems. Especially if that AC system is three-phase. Now, so between AC and DC, okay, so AC is more convenient. Now, even that AC, they have got the option of having the system as three-phase AC or single-phase AC. So again, three-phase is more preferred. The power delivered by a three-phase system is 3 times bigger than the power which is delivered by a single-phase. That's a fact. Therefore, if we are running three-phase motors in terms of delivering power, it would be superior to having single-phase motors. In terms of the economy, cost-effective or something, well, in terms of using, for example, the conductors, yes, that would be much better. In terms of the starting of the motors, yes, that would be better to have three-phase. In terms of, for example, the synchronizing the torque between the mechanical parts of a machine, especially when you are running them in parallel, it would be much better. All right, so the decision between AC and DC is first of all AC. And in AC, between three-phase AC and single-phase AC, it is three-phase AC. All right, so now that it is three-phase, we can have different connection configurations. That AC three-phase could be either star or delta. Of course, we have got zigzag, that I'm not going to talk about it right now. So that the star or Y connection has got a neutral point, but the delta does not have any neutral point. So if the system, let's say the source is a star, and the load is also a star, we have got a number of different options. So we can connect phase A to A, phase B to B, phase C to C, and at the same time we can connect the two neutrals together. So we are using the same conductor for both neutral points. Okay, so that's one of the methods. So this is what we call the three-phase 4-wire system. So basically 4 wires are provided to the customer So if the customer is at the right-hand side, on the right-hand side, 4 wires are provided to the customer. 3 for the phases and 1 for the neutral, and the customer have got the freedom to connect that neutral point to the neutral point of their loads. However, also we have got 3-phase 3-wire. So the utility is not providing the neutral point of their machines to the customer. They say, all right, so why do you want to connect it to your neutral? Well, because I would like to connect the neutral point to the ground. Okay, that's your responsibility. You have to establish your own local ground and connect your neutral to that local ground. If the customer says, no, I'm not going to do that, in that case, the neutral point of them will be floating. And that may not be good in terms of some of the faults that may happen in the system, and they may not be detected at all. Right, okay, so still the source is a star or Y, but this time the load is delta. Again, it has to be 3-phase, 3-wire, okay? Unless the customer says that I'm just going to use an earthing transformer so that I can connect your neutral point to my earthing transformer. But in this case, this is not it. Finally, it is possible that, for example, the source is delta and the load is a star. Well, again, the utility company does not have any neutral point to offer to the customer unless they have used an earthing transformer whose configuration is normally zigzag. All right, so these are different types of configuration and connections. This power distribution can be related to a utility, as I said, or can be related to a residential area, it means domestic loads, or it can be related to industrial loads. So basically the nature of these loads are different. The daily load cycle and consumption and load factor and loading profile and things like that could be different. As a result of that, handling these loads or controlling these loads or connecting them to panels or something, they could be different because in nature they have got differences. However, whatever system you have got for whatever application you may be thinking of, at all the time in some kind of systems, distribution systems, especially for industrial, you have got an incoming supply coming from a transformer, for example, coming from a line or something, okay? So you have got an incoming line, incoming cable, right? And then you have got a step-down transformer. So the primary side of the transformer, you have got something like medium or high voltage, and the secondary side of the transformer, you have got the low voltage or LV. So what happens is that you will connect your distribution panels at the LV side to the transformer. So let's assume the incoming is 11 kV. That 11 kV will then convert into 415 volts. So you would require to have a 415 volts panel with its bus bar, and there will be some outgoing feeders. Of course, you need to have control, SCADA, protection, or something like that, PLC or something. And at some occasions, basically, you may need to have, let's say, something like embedded generation or standby generation or in-plant, in-house generation, emergency power or something that will be connected to the same bus bar at the LV side and sometimes at the HV side. So this is in very general the distribution system that you can think of. So the main equipment in such a system, of course, they are switching devices. Like what? Like circuit breaker, like load break switches, like this kind of thing. So switching is important. Obviously, you need to have a transformer, a step-up transformer, maybe more than one. You need to have panels, HV panels, LV panels, depending on the kind of loads you may have. If you have got motor loads, in that case, you need to have motor control centers, or MCCs. In terms of the control, in terms of the protection, you would be in need of DC power supplies, which comes from battery banks and power, let's say battery chargers. You need to have protection. You need to have obviously an earthing system for your panels, for your transformer, for your cables. On many occasions, you need to have power quality equipment like power conditioning panels, okay, against harmonics, for example, harmonic filters. So these are the different things. And of course, connectors. These connectors could be cable or could be overhead line. So these are the main equipment in a distribution system.